world's largest encapsulation material supplier, Hangzhou First. Stephen Tang, who is an R&D manager at Hangzhou First, is going to give us a brief overview on high-quality encapsulation solutions for heterojunction. Stephen, the floor is yours.
Hi, yeah, good evening, yeah.
Good evening.
Okay. So I will share my screen, yeah.
Mm-hmm.
Okay, yeah, so my name is Kevin Wu from Hangzhou First, yeah. Here is my topic about tonight is packaging solutions to HJT modules. We are talking about the market trend, in the world about, especially about N-type cells. And according to the expectation, HJT will have a market share which is close to 20% in the world in 2025. We all know, there are many advantages about the HJT cells, such as higher efficiency, better passivation, and lower processing temperature, which leads to lower energy cost, and lower temperature coefficient and a thinner thickness, which means cost down. But this also brings several challenges for the encapsulation. We can find the three main concerns on the encapsulation. First one is poor adhesion between film and TCO. And second one is water permeation via edges. This will lead to TCO damages. And the third one is UV-induced degradation. So I'm going to introduce the first challenge, which is poor adhesion and delamination. The failure mode is the poor adhesion will cause delamination, and the delamination leads to more moisture ingress, which leads to TCO damage and a power drop. The solution is to improve the adhesion with the film. Adhesion between encapsulant and HJT, Hangzhou First developed a higher adhesion encapsulant with HJT for all films, including EVA, POE, and EPE. And challenge 2 is moisture ingress. We can find out there are three main encapsulants now in the market: EPE, EVA, and POE. Of course, POE is the best and EPE second. But the water can still go inside from the edge. And our solution for this, the first solution is to have a product we call the edge sealant. The type is PIB 401. It has an excellent barrier property, and also it has an excellent bonding strength with glass, which prevents the penetration of the moisture from the interface. And the second solution is moisture resistance backsheet. We have white backsheet with improved, sorry. The white backsheet with improved, we have two types. One type is the organic one. We put another layer of organic barrier film there. And the second one is to put an aluminum film there. So for the aluminum layer type, we can find out the WVTR keeps close to 0 during the long time aging test. And for organic type, the WVTR can be controlled within 1 gram after damping 3,000 hours. And at the same time, the reflectivity can reach more than 85%. And also we have transparent backsheet. You can find the appearance, which is very similar to glass and to normal transparent backsheet. But this kind of transparent backsheet, we add a transparent barrier film. The WVTR can also be controlled within 1 gram per square meter during long-term aging test. The final backsheet is our black backsheet with high reflectivity, and it can be also improved as an aspect of moisture resistance. We can find the appearance of the bifacial module with high reflectivity black backsheet. The appearance is very perfect with the cells color, and the light transmittance of different cells can also provide another path to improve the reflectivity. Challenge 3 is the UV-induced degradation. Compared to other solar cells, HJT has a larger power drop after UV exposure. After the UV exposure, a significant decrease in the H content was detected, and it is speculated that the passivation effect of the intrinsic MS silicon layer decreased significantly. So our solution 1 is to use UV cutoff encapsulant, such as our TF8, EP308, F806. These are all UV cutoff material. It can block the UV up to 380 nm, but the power loss is also found with the high block UV film compared with UV through film. So this brings our solution 2, UV light conversion film. We can find out from the EQE curve of different cells, HJT cells has a much more room to improve. And you can also find from the right curve that the light transmittance of different films. So Hangzhou First, the UV light conversion film can get an extra 1.2% of power compared with UV through film. If we compare that with UV cutoff film, more than 2% of the power can be added. And this technology, we applied many years ago in the EVA film for POC cells. UV conversion EVA film at that time, has non-obvious power gain compared with UV through EVA film when it's applied in POC cell modules. But we do find out in some POC cells, special one, it gains more power. Here is my last point. There are 2 types of the busbar technology in current market. One is low temperature soldering, and the other is with smart wires technology. For smart wires, it can save silver paste, but we need another additional carrier layer. And the Hangzhou First can provide the 1-layer type of this film. So here comes the summary. For HJT cells encapsulation, there are several challenges: poor adhesion, water ingress, and UV-induced degradation. And according to these 3 challenges, we provide several solutions for it. For the adhesion problem, Hangzhou First already improved all the films of EVA, PLE, and EVA And the bonding strength between the film and the TCO can be above 40 Newton. And for water resistance, Hangzhou First can provide edge sealant and a moisture resistance backsheet, including white, transparent, and black. And to avoid UV-induced degradation, Hangzhou First also developed the UV light conversion film, which can bring more than 1% of the power gain compared with UV through film. And for smart wires technology, we also developed a carrier film. Yeah, that's all. Thank you.
Okay, thank you very much for your presentation. I have one quick question. So this light transferring film, so what is the base? So is it EVA or EPE or POE? I mean, what's the base for it?
That technology can be applied, in all the products of EVA, POE, and EPE. Yeah.
Ah, okay, okay.
Yeah.
That's really interesting. Okay, so thank you very much for your presentation.
Thank you. Yeah.
Thank you. And please stay here, and if there are any questions, please answer them.